Hello, I want to tell you about the Chip-8 visual assembler I've been working on. I've actually done 3 videos on this before, but they were more along the lines of like devlog videos. I never said what this thing is or what you would do with it. So that's this video, kind of the overview. First, let me show you the Chip-8 emulator that Outsider built, which can be found in the Neos Essentials folder. If I pull this thing out and put you somewhere that you can see what we're looking at. So this is an emulator built inside Neos using Logix that emulates the Chip-8 CPU, which the Chip-8 CPU was never an actual CPU that was like built physically, but back in the era of 8-bit computers, it was a virtual CPU that programs, especially games, could be written to that could run on a variety of different 8-bit computers, so people could share their programs even when they had different types of computers. And you can see I just plugged the cartridge into it there, which contains a program, or is a representation of a program. There it goes. And this one just happens to be a game of Tetris. So most people saw this emulator that Outsider built, and they said, "Oh, that's really neat. We can play Tetris inside Neos." I saw this emulator that Outsider built, and I said, "Oh, how can I program that?" So if you look at any of these cartridges that Outsider provided for use with his Chip-8 emulator, like this one, which is a simple example program, if you run this, it draws a maze on the screen. But you can take one of these cartridges, and if I had prepped for this video properly, I'd already have the tools out. So you can examine this cartridge here and see right in the tag of the ROM. This is actually the machine code. So this is the... Oh, come on. Okay, there we go. So this is the actual machine code for that maze program. So if you wanted to write a program for the Chip-8 emulator here, you could go in and just edit this string of hexadecimal numbers and write a program. So inside this program code here, every 2 bytes, which is every set of two character numbers, that's one operation within the Chip-8 CPU. Like this first one you see, it says 6000, and you can go to a reference here, and you can see that 60 is load register X with byte. So this says load register 0 with byte 0. And this next one says load register 1 with byte 0, and so on. And you could write a program just by typing out the hexadecimal numbers, but that would be rather cumbersome. And if this is hard to read for you, it is also hard to read for me. So what you normally do is use an assembler where you can write out more human readable text, like LD for load, or add for addition, or SE for skip next instruction. You write those out in a text document, and it compiles them into this. And the other thing that is really handy about an assembler is that a lot of these operations, when you're programming the CPU, use addresses. So like jump to address, call address, and so on. And if you were writing out the machine code directly into a file, then say that this operation up in front here had to jump to a subroutine down here, then every time that you change the length of the code in between, you'd have to go edit this operation here to change the address that it jumps to, because that target is moving around. So the other thing that assemblers do is they let you put labels in your program, and you can jump to a label, and then when you assemble it from text into the machine code, it goes in and calculates the memory location for each of your labels in your assembly file and writes them into the machine code for you without having to track that yourself. So my first thought was, okay, if I want to program this wonderful emulator all in Neos, then I'm going to have to write an assembler. So I'd have to write a bit of logics that parses through things that say, clear screen, return, jump, call, and assembles them into machine code. And since we don't even have an actual text editor in Neos, that just didn't seem like it would be convenient. And my second thought was, inspired by the visual scripting logic system, in Neos, I'm used to just plugging all these nodes together to write a program. So why not write a visual assembler instead of a text assembler? It would be kind of like, if you're familiar with other node-based programming languages like Scratch, it would look kind of like that, but it would be a visual representation of assembly instead of a higher level language. So it would still be a very low level language, just a visual representation of it. So that visual representation of assembly language is what I have done here. If you look at this stack of things behind me, each of these colored nodes or boxes or cubes or whatever you want to call them represents an assembly or a machine language operation, and you just write them out and stack them together to form a program. So this program right here is actually the same maze program as I pulled out of that ROM a minute ago. So if we look at this program here, it started with the same, load register 0 with 0, load register 1 with 0, and so on, all the way down the program. And if you hit assemble, it scans through these nodes and compiles them into this machine code, and also generates a little ROM cartridge for you, which will run in the Chip-8 emulator from Outsider. And these can be taken apart and snapped together visually instead of writing in a text editor. And to do the address references where you want to give this node a reference to the location of this data here, you just pull out a little address reference thing from the right side here, connect it up to that node, and then even as the address of this node changes, this will maintain the correct address to reference that data. So this data is at 222 right now, and if I were to, say, rearrange these things, now that data is at 21E, and this node over here has updated its reference address to 21E. So you don't have to go manually edit these addresses anymore. It, just like a text assembler, it keeps track of that for you. And I have implemented all of the Chip-8 opcodes, so you can pretty much write any Chip-8 program with this now. Okay, and they are available in my public folder under, this is the wrong path, you won't see that, but under Chip-8 ASM nodes, you got all the various types, and meta is things like the start of program, end of program, a relay node that lets you connect two stacks without having to make them into one giant vertical stack, stuff like that. Labels, they do have labels, and you can drag, like this one is a label, you can drag a address reference to the label instead of to one of the nodes under it, and it will maintain the correct address for you. So this program here generated this little ROM, and we can plug that in here just to see that it really does work. So that is the same maze program. You can see it works. And to show you that it can be used to make your own arbitrary programs um, instead of loading a predefined one. I'll try that here. This is the first time I've actually tried to write any program for the thing, so we'll see how that works. So I'm going to need my reference document here if I want to write a custom program for the Chip-8 thing. Just start out with a start node. You'd think I could remember what category to look for these nodes in, considering I'm the one that created the whole thing. I'm just going to name this a test program. And let's say we want to start out with something super simple. So, for instance, just clear the screen. So that would be under I/O. We have a CLS node. So we have a start, a clear screen, and an end program, which an end just jumps to its own address and loops forever so that the CPU doesn't try to go execute random stuff in memory. So this start, clear screen, end. Okay, assemble it. There's our program, 00E01202. That is a very small program, and that's just clear screen and then an operation that loops on itself. So let's plug this into our Chip-8 emulator, or Outsider's Chip-8 emulator. See if it works. That is not what I expected. Okay, after a quick bug fix, we're back. I had to change the root slot. I'm sorry, not the root slot, the start node. It had a bug in its assembler. It was saving the machine code to the wrong slot. It should be fixed now. So if I pull out a new start, and I just pull those nodes over to the new start and delete the old one, this one should actually work. So we have a ROM. Let's go plug it into the emulator here. Turn it on, hit reset, and it does clear the screen. So I think it's working. You know, it's kind of hard to tell when all you're seeing is a blank screen. So let's see if we can do something a little more complicated just to see that it's working. Like I said, I have not actually worked with this before, so bear with me for a moment. So this says put an 8 into register 0, and then we load the sprite for the digit from register 0, which is 8, into register I. Then load 0 into register 1, 0 into register 2. And then we want to draw at location of registers 1 and 2 the data. How many bytes? I think it's 5 for the 5 vertical, because sprites are always 1 byte or 8 bits wide. So data, I guess, would be 05. Okay, so start, clear screen, and then after the clear screen we want to draw an 8 in the upper left corner, and then end program. That gave us a slightly longer program. Let's see if it works. It did. We have an 8 in the upper left corner. So you can see it actually is letting me program the Chip-8 in assembly with, visually assembled nodes for the assembly, which is pretty neat. And these programs would actually run on any Chip-8 emulator. It doesn't have to be the one in Neos. So if you wanted, you could export that data and run it on any Chip-8 emulator, even though it was built with this big stack of nodes here in Neos. So anyway, that's what the Chip-8 visual assembler is for and how it works. And that was probably a rather more confusing video than I had intended, but it'll have to do.